Okay, so this is actually a chapter 4 topic, secondary structure. So which intermolecular forces are involved in maintaining the secondary structure of a protein, and which groups are involved? So this is kind of a straight recall of concepts from our discussion of the hierarchical nature of protein structure. So remember that secondary structure is solely related to hydrogen bonds. So the hydrogen bonds is our intermolecular force that's involved, okay, between backbone atoms. And I'll put a comma there specifically because we're asked what groups. The carbonyl oxygen of the peptide bond on one amino acid residue with the hydrogen attached to the nitrogen of the amide bond on another amino acid residue. Okay, so let's look a little bit more into secondary structure, okay? So the next problem asks you to interpret a structural diagram, and then we're going to take sequence from that diagram and try to analyze it in terms of stability, okay? So we begin by looking at the structure shown in what's known as a ribbon diagram of the beta-lactamase molecule. Okay, so this is known as a ribbon diagram. All right, so on the figure above, we're asked to label two types of secondary structure found in the molecule. All right, so the two types that are easiest to identify on this type of diagram would be, alpha helices and beta sheets. Okay, so we've got an alpha helix right here, right? And I'm going to change color so it shows up more. Right here, okay, we have a beta sheet. Now we want to be as specific as possible. So let's look at our beta sheet first, and we would characterize it by both the number of strands and whether they're parallel or anti-parallel. So let's look. So we've got 1, 2, 3, 4, 5. So this is a 5-stranded beta sheet. And is it parallel or anti-parallel? Well, my arrows are pointing in opposite directions, right? So this is an anti-parallel. So this is a 5-stranded anti-parallel beta sheet. Can we say anything else about the alpha helix? Well, let's look at it. Okay, so the alpha helix, we can tell if it's right or left-handed by tracing the way it coils. Okay, we have a little depth in this diagram. So if I were to take my right hand and to curve up along the way the backbone is, and it traces the backbone, that is a right-handed sheet. If I were to take my left hand and curve up, that would be left-handed. And if I tried to do that, you'll notice that I would not be following the thing. So this is a right-handed alpha helix. Okay, so the other thing that we can tell about this helix is where the N and C terminal ends of the helix are and what direction the helix dipole points. Okay, so you'll notice that I have, this is a terminus. It's the end of the molecule here. So end of peptide chain. So the question is it the N or the C? And this is where I need the help of my beta strands. So you'll notice that this helix is attached to a beta strand, and the beta strand has the arrow pointing this way, okay, because you see the flat end there. So the arrow is pointing towards the C end, so the flat end is at the N terminus. Okay, so this must be the N terminus of the molecule. So this is the amino terminus, also known as the N terminus. Okay, so, all right, so if I look just at this helix, okay, then if this is the N terminus, then this has to be the end of the helix that's closer to the C terminal end. So if I were to add in the charges, this end of the helix, okay, would be the negative end of the helix dipole, and this end of the helix would be the positive end of the helix dipole. And so my helix dipole, okay, would be pointing in this direction. So this is the helix dipole. All right, so that's, I think, about as much as we're going to get from this ribbon diagram at this time. And so we're going to stop there.